There's Mr. Craig. Looks like we got a few kinematics problems to deal with here. Okay. And they all seem to be Halloween themed. So let's get right into it. Start with part A, where the witch throws her broom up into the air and goes straight, comes straight back down, and we know it has an initial velocity of 13 meters per second. Okay. Now with kinematics equation problems, there's always several ways to solve it. For objects that are falling, I think the simplest one is always to use this middle kinematics equations. The final position equals the initial position plus the initial velocity times time times what, or plus 1/2 at squared. So that's what I'm going to use for this one. And you'll see why, because good things happen when you do. Actually, got to change to a different board. Okay. So if we call this ground level as y equals 0. Okay. Both the position and starting position are 0, so those terms go away. Okay. So we'll do that on the next board. So y final equals y initial plus v initial times time plus 1/2. And since we're working in the y direction, our acceleration is going to be little g times t squared. Okay. Now, as I said, we can cancel these out. They're both 0. So we're left with 0 equals the initial velocity, okay, which is 13. That's back 3. 13. Okay. Times the time plus 1/2 gt squared. Okay. Now this is really nice because we can pull t out of both of these terms. Okay. So 0 equals t times 13 plus 1/2, sorry about that too, gt squared. Sorry, not squared anymore. Pull that out. Okay. Right. And both of these factors, okay, recalling back to algebra, have to equal 0. Okay, so we know that at time 0, okay, when the first throws the broom, it's going to be at ground level. Okay. What we're more concerned about is what's in the parentheses. And that's what's going to give us the time it was in the air. Okay. So we have 0 is equal to 13 plus 1/2 gt. Okay. And now we just rearrange the equation. So subtract 13 and multiply by 2. Okay. So we get negative 26. And then all divided by g, and remember g is 9.8, but in there as well is a negative sign. So we do negative 9.8. And if I pull out my handy calculator, that's going to give us our time. Okay. And it's going to be positive. Okay. If you get a negative number for time, probably forgotten a sign somewhere. So 26 divided by 9.8 okay, is about 2.65 seconds. is the time that it takes to go up and come back down. Okay, so there's your answer for the first part. Okay, for the second part, a zombie is walking along the edge of a cliff and accidentally missteps, okay, causing him to fall vertically straight down to the ground below. Okay. The zombie reaches the ground below 8 seconds after falling. How high is the cliff? Okay. Again, I'm going to want to use the second equation. It deals with everything that's given in this problem. It's got distance, okay, it's got time. Again, we know the acceleration due to gravity, and it doesn't explicitly say it in the problem, but it looks like, or if he's walking off a cliff, his initial velocity in the y direction, I think like the instant you drop something, is 0. Okay. So we're going to use that equation again. So y final equals y initial plus the initial times time plus 1/2, and again gt squared. Okay. All right. So if we set the ground as 0, okay, so the cliff is, what was it? But we don't know how high the cliff is, but cliff some distance above the ground. Let's set the ground at 0. Okay, that means we can set y final equal to 0 and cancel that term out. Okay, and as I said just a few seconds ago, okay, that second you drop something, its velocity is 0, and then it starts accelerating. So we can actually cancel this term out too. Okay, so what we're left with is 0 equals y initial plus 1/2 g t squared. Okay. Again, now it's just rearranging the equation, and this one's pretty easy because we just take this term and move it over to the other side of the equal. Okay. So we get negative 1/2 gt squared equals y initial. Okay. I'm going to scroll over. Okay. So 1/2 times g is 4.9. And we've got a negative sign right here. Okay. And there's also a negative sign in that g. So we've got a positive number. That's good. Okay, so we've got 1/2 times 9.8 is 4.9 times the time it took, okay, the 8.7 seconds. And that time is squared. Okay, and that gives us our initial height. Okay, so again, going back to the handy dandy calculator. Okay, 8.7 times 8.7 times 4.9, and we get a y initial about we'll call it 371 meters. Okay. So there's for your second part. And last question. Okay. The rooftop of a building is 18 meters above the ground. A boy drops a tennis ball to his friend waiting to catch the ball outside of a window from the same building. When the friend catches the ball, it has a velocity of 12 meters per second. How far above the ground is the window that the friend's at? Okay. This time, okay, we don't have a whole lot of information for the second equation. Okay, so we've got to choose between the first and the last. Okay. Okay. Problem with the first is this is asking for a distance. Okay. There's there's nothing to do with distance in that first equation, that top equation, okay, but there is in that bottom one. Okay. So we're going to use that one to solve this final question. I'm sorry this video is so long, there's a lot to go through. Okay. So the equation for this one is VF, final velocity squared, equals VI, the initial velocity squared, plus 2. And again, we're going up and down. Okay, so G, okay, and then the change in Y. Okay, so good news is there's one more thing, or we can cancel something out again. Okay, drops the ball, initial velocity cancels out at 0. We know the final velocity, told us that in the problem, okay, was 12 meters per second. So let's plug that in and work from there. Sorry about that. Okay. So we get 12 squared equals 2g and the change in the height. Okay. All right. So 12 squared is 144. Okay. So I'm going to put that here, and then I'm going to get that delta y alone. So I get 2g. Okay. All right. Okay. Again, plugging that into the calculator, 2g is 19.6. And again, negative. So negative. Okay. And plugging that in gives me negative 7.35. Okay, so it's fallen 7.35 meters. Okay, and don't forget our units. Meters. Okay. Obviously, this one has a negative sign in it. That just means it's going down. Okay. Okay, so if it's this isn't our final answer though. It's asking how high above the ground it is. Okay. So if we know we started at 18 meters and it fell 7.35, okay, we'll call this H for height. Okay. All right. And just to make sure I don't make any silly math mistakes in my head, I'll do it in the calculator. Okay. All right. So I get a height of 10.65 meters. Okay. And again, that's how high above the ground it is, not how far it's fallen. How far it's fallen is this 7.35. Okay. Right. I hope that helped out. If you have any more questions, feel free to post them or schedule a tutoring session with me. Thanks and have a good day.